All right. Hello, everybody, and happy Tuesday. This is Miss Scrippa. I'm going to do a quick, very, very short lesson with you guys about carrying capacity today, just because there weren't really very many good ones on the internet that were not totally cringeworthy, and that went over what we're really going to focus on for this class. From now until the end of our summer school course next week, we're probably going to be doing things that you haven't really seen before that should be pretty new. Because this, at least for my class, was about where I ended up when we left school and started doing classes remotely, which I know a lot of people struggled with. So if this is brand new to you, that's okay. We're going to take our time with it as best as we can. Just a quick update. I know the calendar I originally sent you guys at the very beginning of our class said that we were going through not this week's Thursday, but the Thursday after. But I got some updates from Mr. Dowd, who runs the program, and they're actually going to be finishing summer school a little bit early for you guys. So we actually have 1 week from today. So today, Wednesday, and Thursday, we'll have assignments. And then next week, Monday and Tuesday, you'll have assignments. And then late work will be due on Wednesday. So we have a full week this week, and then a half week next week, and then we were all done. All right, and I'll put this elsewhere as well with this announcement in case you don't keep track. I'm sure you'll hear a lot from me about that in the future. But for now, we're going to worry about something called carrying capacity. And where we are for today and also tomorrow and Friday are we're going to start talking about some ecology. And ecology just means that we're studying ecosystems. So we're studying how many animals can live in an ecosystem, how they interact with each other, and things like that. So that's what we're focusing on. And the first topic that we're really going to care about for today is carrying capacity. So carrying capacity is the number of individuals of one species that an environment can support. So it's thinking about, okay, say we're looking at a certain area, and that area can be whatever size you like. It could be the size of Springfield. It could be, we could be talking about the carrying capacity of all of North America. But it's the number of individuals that the environment can support, right? So if you think about it, I actually have a fish tank at home, right? And I can fit 5 fish in my fish tank pretty easily, and they have enough space and enough food and enough water for all of them, right? But at some point, you're going to hit a limit where you're going to say, okay, no more fish can really live in this tank, right? At some point, you start to have this left scenario, right? So it's how many animals or plants can actually live in this area realistically? How many animals can we feed with the amount of food that's around? How many animals can have shelter given the amount of space that's around? Right, so carrying capacity is how many animals or plants can actually live in that area and still have the things that they need to survive. Carrying capacity depends on the amount of resources available. And you've probably heard this word resources or even natural resources before. All right, a resource is a very general word, and all that it means is it's something that living things need to survive, but it's also something where it's limited in supply. It's not endless. So, for example, water is something that all living things need to survive, right? And there's not unlimited water, right? If you think about drinking water in Springfield, eventually we could hit a point where there's not enough drinking water for anybody else, right? So that's something that's going to limit the number of people or animals or plants that can live in an area. A very common limiting resource would be food, right? Whether you're a rabbit or a wolf or a whale, right? At some point, you might not have enough food to feed all of those animals, right? So that's another thing that's going to limit the carrying capacity. It's going to limit the number of animals that can live somewhere. There also might be space, right? Eventually, you're not going to be able to fit any more animals or plants, right? Eventually, they're all going to be kind of on top of each other. So we're limited by the amount of space for things to survive. And especially if you're a plant, things like sunlight, all right, plants all need sunlight to grow, and that's going to limit the number of plants that are around there. If you have too many plants, they're probably going to be stuck in the shade and can't get any sun, all right? But again, carrying capacity is just how many animals or plants can live in an area, right? And how many can live there just depends on what resources there are. All right. I know this one has a lot of words, but it's just a couple of examples. A carrying capacity can actually change over time. It's not always the same number. It probably stays the same number for a long time, but every once in a while, something might happen that can change the carrying capacity. So, for example, say you're an animal that's very limited by the amount of food, right? Maybe the amount of food is what's limiting the number of that animal. If all of a sudden you have a new source of food coming around, suddenly more animals are going to be able to live in that area, right? So the more food you have, if you add food, your carrying capacity is going to go up. More animals could live there and eat that food, right? And on the other hand, say you have a natural disaster like a tornado that comes in or a hurricane that's destroying the habitat. Maybe it cuts down a whole bunch of trees and causes a lot of flooding and kills a lot of the plants there, right? That carrying capacity is going to decrease because now all of a sudden, maybe we don't have enough food for everybody because it was destroyed in the disaster, right? Or maybe there's not enough space for all the animals because now some of it is underwater and being flooded. All right, so every once in a while, this capacity can change. And I believe at the very end of the questions, your job is going to be to look at some scenarios and decide if that would change the number of animals that could live there. A lot of times scientists like to graph carrying capacity over time. So say this on the bottom, the x-axis, say this is number of years, right? 0 to 200 years. We could count the number of trees or whatever else are living in an area, right? We could count the number of trees living in an area and it might go up. We might get more and more trees. But at a certain point, it can't just go up and up forever, right? You can't have unlimited trees. Eventually, you're going to have as many trees as there can fit, right? You're not going to have 18 trillion trees. I mean, I guess you could, but eventually, whatever that number might be, there's not going to be enough sunlight or nutrients or water. So in this case, the populations of trees went up and up and up for about 100 years. And around 100 and 125 years, they probably ran out of space or water. And eventually, this is kind of the maximum number of trees that could live in that area, right? They hit 10,000 and then it stopped. They couldn't really fit any more trees. In real life, carrying capacity is not always this beautiful flat line that we see in graphs all the time, right? Because it's nature, and nature isn't always perfectly going to fit in with math. So sometimes our carrying capacity might look a little bit squiggly like this pink line here. But the important thing is it's hovering, it's staying around this carrying capacity, right? Eventually, if we're talking about in millions of something, right, eventually you're going to hit the limit of amount of food or water, and it's going to stay about the same number. It might not stay exact because nature isn't, very exact a lot of times, but it might be around that number, that carrying capacity. Right? But just to review, carrying capacity, we're talking about the number of individuals of one species that an environment can support. So say how many frogs can live in the Amazon forest, right? How much food do they have available? Eventually, you're going to have a certain number of frogs that's the maximum. You're not going to have 12 billion frogs because eventually there's not going to be enough bugs to feed them, right? So it's how many realistically can you fit before you hit overpopulation. All right. But please let me know if you guys need any extra help today. All right, I'm going to be around, but that is about it from there.